Hello everyone, hope you're having a great day. In today's video we're going to have a Python code sentiment analysis app. Sentiment analysis is very useful in different settings. It's used for customer feedback analysis, market research, social media analytics such as platforms like Twitter, Facebook, and Instagram. So they generate massive amount of user-generated content. So the sentiment analysis helped them to understand public opinion or trending topics. Also using financial markets or content moderations. It's a very good application that can be integrated to other apps to help with a lot of analyzing day-to-day operation for those applications. The app that we're going to use today is designed to learn from a data set of labeled songs and then use that knowledge to predict whether new reviews are positive, negative. It uses machine learning and text processing. So let's go ahead and have a look at our application. This is what I've developed here. And we have a CSV file here that we're going to use as our data. So as you can see, the file has two columns, review and sentiment. So the review could be anything like I love the song, it's amazing and uplifting, and sentiment could be positive, negative, or neutral. This source of data is what our application will use to train the model. And later on in the app, we're going to give it some new info, like a few new rows. And then we want the application to make a guess whether those are positive or negative. We're doing that right here. As you can see, I've given it some positive and negative reviews. Then after the app analyzes the data set we're giving to it, it'll make a prediction whether those statements are negative or positive. So I'm going to run the app. And yes, this is what we see, the accuracy of our data prediction. We have something called classification report, which we're going to dive into it a little bit deeper later. And these are the result, the prediction result. So the app predicted that the first statement is positive, which it is, and the next two are negative, which in fact they are. So this shows that the application is functioning as expected. Few things that we're going to go over in this app is Python AI tutorial step by step, text classification, machine learning, and naive Bayes machine learning model. So let's have a high level review of our application before we jump into coding part. This could apply to most of the machine learning projects. Okay, so the first phase is always data loading. So the application starts by loading the data set that we've given to it, which in this case is the song reviews from a CSV file. Each review in the dataset has an associated sentiment label, positive, negative, or neutral. Second step would be data preparation. So the application cleans up the dataset by removing any entries with a neutral sentiment label. This simplifies the task to just classifying reviews as either positive or negative. The text data, which is reviews, is then transformed into numerical data using a technique called bag of words, which converts the text into metrics of word counts, where each word in the review is treated as a feature. And we're going to use a method to handle this transformation. Then we have model training, which the data set is split into two parts, a training set and a test set. The training set is used to teach a naive Bayes classifier to recognize patterns in the word associated with the positive or negative reviews. After training, the model is tested on the test set to evaluate its performance. Fourth step would be evaluation. The application evaluates the trained model by calculating how accurately it can predict the sentiment of the test reviews. Key metrics like accuracy and classification report, including precision, recall, and F1 score, are generated to assess the model's performance. Then the next step and the final step would be prediction. Finally, the application includes a function that allows the user to input a new song review and get a sentiment prediction, positive or negative, from the trained model. This demonstrates how the model can be used for real sentiment analysis on new data. All right, let's jump into our application. We need to import a few packages. First, Panda, which is used for data manipulation, and Count Vectorizer for converting text into numerical data. Scikit-learn components used for model training and evaluation. Train test split for splitting test and train. And the next one would be multinomial NB is our algorithm. We imported from naive bias. And also we have metrics, which is used for accuracy score and classification report. We import those from scikit-learn.metrics as well. So next step after this, we need to load the data set of song reviews from the CSV file we have. And as I said, the CSV file contains two columns, review and sentiment. So pd.read CSV is the method. Then we need to give it the file name. Then, as you remember, we had also a neutral sentiment, which we don't need it for our application. So we need to remove that. We need to simplify the classification task. That's what we're doing here right now. So we're going to say it's not equal to. We need to go right. Okay. Give me 1 second. Yep, here. Not equal to neutral. Okay, the next step, we need to convert text data, which is the song reviews, into numerical feature vector using the bag of words model we talked about. It works by counting the frequency of a word in each document. In our case, is each review, and converting that into a vector of numbers. So machine learning model can't work directly with raw text. We need numbers. So the text needs to be converted into a form that can be used for mathematical operations. That's where count vectorizer method comes in. So max feature 2000 limits the number of unique words, which we also call features, to 2000 most frequent ones. Limiting the number of features helps reduce the complexity of the model and can prevent any overfitting. In a large data set with many unique words, which this one is not the case, using all the words as feature could be create a very high demanding, high dimensional feature space actually, which might not improve the model performance and could make like a training kind of slower. So by focusing on the most frequent words, the model can capture the most important information while ignoring less relevant data. So fit transform is a method that performs two stages in one. The first one is fit, which the count vector learns the vocabulary from the trained data. Let's say it's looks at all the reviews and identifies the top 2,000 most frequent words. Then we have the transform part, which is transform each review into a vector where each element represents the count of a specific word in that reviews. So the result is a sparse matrix where the rows represent reviews and column represent words. So X is the features review text. If you have a review like "this is amazing song," the vectorizer might convert that into a feature vector like 0101 whatever, where each number corresponds to the frequency of a certain word in the review. So here X represents the features, which are the transformed text reviews, and Y will extract the target labels, in this case the sentiment of each review, from the data frame. The Y variable will hold the sentiment values like positive or negative corresponding to each review. So the model needs to know which label corresponds to each review so it can learn and associate certain patterns in the text or features with the specific sentiments or labels. During training, the model uses this labels information to make prediction and adjust itself to the improve accuracy. Alright, so put it into another word, labels or sentiments are the target variables that the model is trying to predict. If the review is "this song is amazing," has a positive sentiment, then the corresponding label would be positive. Also bear in mind that we have the X as uppercase, which is a common practice. Alright, so next step we're going to use train test split method, which splits the data set into training and testing sets. So we're going to allocate 80% of the data to use for training the model, while only the remaining 20% reserved for testing the model's accuracy. And we're gonna have something called random state, which we're gonna set it to 42, which will ensure that the split remains consistent across different runs. If we don't set that, every time we run the application, the accuracy will be different. We don't have a large amount of data. We're working with a small amount of data. So it is important that we set this element. All right, so the test size 0.2, which indicate 20% will be allocated for testing, and the random state 42 will help us to control the randomness of the data splitting process. And now we need to initialize the naive Bayes classifier, and multinomia NB is what we're going to use as our algorithm, which is a classifier that is chosen because it performs well on the text classification tasks, where the features are word counts or frequencies. Then we need to train the naive Bayes classifier using the training data, features, and labels, so they can learn to associate with word patterns with positive or negative sentiments. So we're going to use a method called fit, and we're going to pass with xtrain and ytrain variables. And then we're going to use the trained model to predict sentiments for the test data. So predict sentiments, naive Bayes model. We're going to use a method called predict. We're going to pass to it x test. Next step, we need to evaluate the model's performance by calculating the accuracy and generating a classification report. So accuracy score computes the ratio of correct predictions to the total number of predictions. And classification reports provide precision, recall, and F1 score for each class. I'm going to dig a little deeper into this later in the app, but let's go do this first. So we're going to say F accuracy, and we're going to have accuracy score of Y test and predicted sentiments. All right, we're going to do the same thing for classification report. So print F classification report. I'm going to put in the next line. We're going to use the method classification report. Then we're going to use the Y test and predicted sentiments. Okay, now we need a method, a function that takes a new review text as an input, vectorize it using the same count vectorizer that we did have before, and predict its sentiment using the train model. So the predict sentiment would be positive or negative after it has been predicted. So the method would return it. So this is our method. We're gonna have a argument in it. So in the method, we're only gonna do the transform step, not fit anymore. So because it uses the vocabulary that was learned during the fit phase we had before, like during the fit transform method that we did, and converts the new text data into the feature vectors based on the existing vocabulary. We do not need any new vocabulary. We already have what we need. So we use transform when you want to apply the same transformation based on the learned vocabulary that we have to new or unseen data. Typically, this is done on the test data or new data that you want to predict. You don't want to vectorize to learn a new vocabulary from the test data, as this could introduce bias or leakage from the test set into a model. Okay, now that we have new review vector, we're going to use the train model to predict the sentiment, either positive or negative. So we're going to have a prediction here. We're going to use naive base model dot predict, and we're going to pass to it new review vector, which is the transformed data. All right. Okay, at the end, we want to return the predicted sentiment as a string. So we're going to pass the first one. So now the only thing is left is to test the sentiment prediction function with sample song reviews that we're going to input and pass into our function. So let's say I absolutely love this song. It's fantastic. So it's a positive review. And then we're going to have negative reviews and stuff like that. So we're going to say, I don't know, I didn't enjoy the song, or I didn't enjoy this track. It's not good. Something negative. Yeah, I didn't enjoy this track. It's not good. So we expect our application to predict the first one as positive and the second one as negative. And also The third one is -2 because I'm going to give it a negative review. Special. All right, we are looking good. Now the only thing left is to run the app and see what's going to happen. Okay, here we go. Yep. Positive, negative, negative. That's exactly what we wanted. All right, so let's have a look at the report. First of all is the accuracy. It shows how accurate our model is trained to predict the data. So precision, it answers the question of all the instances that the model predicted as positive, how many were actually positive? So a high precision means that when the model predicts a positive class, it's usually correct. Okay, so here we have precision negative as 50%. So it means 50% of the instances that predicted as negative were actually negative. And positive is 100%, which means of the instances that predicted as positive, 100% were actually positive. And recall answers the question of all the actual positive instances. How many did the model correctly identify? When we have a high recall, it means that the model is good at capturing the positive instances, even if it's sometimes misclassifies negative as positive. So negative recall is 100%, which means 100% of all the actual negative instances were correctly identified. And positive 50%, which is half of the positive instances, were correctly identified. And what else do we have? F1 score is it's the mean of precision and recall. It combines both metrics into a single score, giving you a balance between precision and recall. So negative 67 means a balance between precision and recall. And same goes for positive. And support is the number of actual occurrences of each class in the dataset. It simply tells you how many sample belong to each class of negative or positive. So support of -1 means there's one negative instances in the dataset, and 2 means there are 2 positive instances in the dataset. Macro average calculates the average of precision, recall, and F1 score across all the classes without taking class frequency into account. Weighted average calculates the average precision, recall, and F1 score across all the classes, but it does take the class frequency, aka support, into account. All right. And that's all. All right, this was a longer application than I expected. Thank you so much, everyone, for watching this video. I really do hope you enjoyed watching it and you learned from it. If you have any video ideas, any comment, any question, please don't forget to do so at the comment section. I'll also put a link to the code in the description. You can go ahead and download it from my GitHub page. And as usual, if you like watching this video, guys, please go ahead and give me a like, subscribe, or a comment below. I really appreciate that. Thank you again. Have a great day.